So I'm going to let them in. Right, we are all in. Good morning, everybody. Welcome to the DSM network. Steve, it's 9:30. We can probably start. Alan.
Okay, welcome everyone. So the background to this, as many of you know, is that Steve did a three-part course on digitalization and Industry 4.0, and some people said that that was great, but there are some people that really just want to know what digitalization can do for them. So Steve has kindly offered to run a lecture now on exactly that. What can digitalization do for me? Apply low cost, low skill, low risk Industry 4.0 solutions for business improvement. Just chatting to Steve, it's our longest day of the year and it's Australia's shortest. So they're completely 180-degree out of phase from us, which is an interesting concept. So without further ado, I'll pass over to Steve. Thanks, Steve.
Thank you, Alan, for the introduction. And now Alan's given everyone the title. And well, I'll just maybe tell you what I'm going to be doing. So I've got the presentation. I've also got the hardware set up, some example hardware set up. So I'd like at the end to maybe have some time to sort of go over that and show people what I'm talking about. But that's going to be a more free-form activity. Okay, so what can digitalization do for me? Now, if you've seen the course, you'll see that I've actually let's get this right, get the right focus. I usually subtitle it "How to Nail Jelly to the Wall." And you might say, well, why do I do that? Well, because potentially if you start with proper jelly, it's very, very hard to nail up. It slips through the nails no matter what you do. So the way you can do that is to actually change the jelly. So this is a little bit about changing the jelly. How can we achieve that low cost, low code Industry 4.0 that I talk about? And so that's essentially what the three short courses were all about. It was getting to the how. So there were three lectures or three workshops, and I broke it into stages. And the first stage was to try and show why I should even try and nail this jelly up, if I keep that analogy going. And that's the vision of Industry 4.0. And the second stage, what jelly should I fasten to the wall? And that's essentially was the second activity, and that was trying to identify a business model that we would use to apply Industry 4.2. And finally, the third course was about, or the third short lecture was essentially about how to do this. And I was able to show some implementation patterns and some implementation hardware. So I'm going to essentially in this presentation, I'm going to sort of turn it on its head a little bit. And I'll give you this meme. What if I told you there's no Industry 4? I don't know who's familiar. If you've all got your film heads on, you know what that's from. It's The Matrix. But why on earth would I tell you? Why would I actually sit here and tell you that there's no Industry 4.0? Well, really, I want you to just use it as to focus, really. And the focus is about what is the hype versus what is the reality. And the little asterisk there was, of course, it's actually quite a lot like the Matrix in itself. It's a bit of a Matrix reference. But what I'm going to do is I'm going to, in the beginning of this talk, is actually go over the original model for Industry 4.0 that I think a lot of you will be familiar with. And then I'll talk about what Industry 4 has turned into for the big players. And I want to try and do this because I want to sort of illustrate the gap between digitization or digitalization for an SME, or as compared to the offerings of some of the large companies, and sort of see how how they've diverged and how that can be converged again. And so to do that, I'm going to sort of try and define what we want Industry 4 to be for us as SMEs. And that's essentially a focus on digitalization. And I want to really highlight what Industry 4 can be today. And I might use the term the smart enough factory. In fact, I will be using it quite often. But that's this concept of good enough is good enough. And that's where the smart enough factory comes from. And I've highlighted it in red. But the point is that, and we'll see if I can get the message over really, but we really need to be business driven in terms of digitalization and not technology driven. And I think that's the issue that's happened with Industry 4.0. So let's have a look at this original diagram of Industry 4, which I'm sure a lot of people have seen. And we have got a very small audience today, but I think a lot of people will be joining us online. And this is something that we saw, well, I don't want to spoil it, but about a decade ago, it's 2011. This was the view of Industry 4.0 that was sort of sold in the industrialized countries around the world. That Industry 4 was about a progression from Industry 1, with that mechanical loom there as an example, to Industry 2, with the slaughterhouses and the electrification of production lines, and they're quite clever to use that rather than the sort of Ford example. I suppose this is the first production line. And then there's a big gap in terms of time, but then we get to the 70s, or in fact the late 60s, when you see PLCs. Now, perhaps it's an interesting one. Your mind wanders when you look at this and you can sort of think, well, okay, which came first, the PLC or the robot? And I'm pretty sure it was a robot. But yes, anyway, that's a chicken and egg sort of question for you. But the next one, the final one, is what we're talking about, Industry 4. And it's this fourth industrial revolution. And it's based on cyber physical systems. And you'll see the axis. Hopefully you can see my mouse okay. Can you confirm that my mouse is visible?
Yeah, you can see it.
Great. Okay, we've got complexity coming up on the side here. That's a fantastic diagram. There's a problem with it though. It's great, and that's the problem with it. It's too good. It imposes its view on us, and it shows this stepwise progression, 1, 2, 3, 4. And it implies it's correct, of course, but the issues, of course, are those divisions so clear cut. Is 4 so different from 3? And I'll come back to that at the end of this. And is complexity really increasing? I think we ought to question that. And industrial revolution itself, was it only about manufacturing? Well, of course, Industry 4, as defined in Germany and the UK, and I think in Australia as well, it's essentially focusing on manufacturing. If you go to the US, it's a bit more industrial, and it covers cities and healthcare and things like that. But of course, it is much broader than just manufacturing. And in fact, the Industrial Revolution was much broader than just manufacturing, of course. But I would also want to just highlight and say, look where today is. Today is always shown, of course, it's a static diagram. It will always be shown as a transition, where we are now to this revolution in ahead of us. But if we really look at that figure, it's actually quite good. I mean, what's the difference between 3 and 4? Still got a robot there, but look, those small devices, and it's Wi-Fi, it's smartphones. And it sort of gets you on thinking about digital twins. And that's really what we're going to say, that is 3 or is 4 so really different from 3. And of course, I've highlighted the year that this was done and who did it. It was a German Research Centre for Artificial Intelligence. Now, coming back to today, and if I was learning about Industry 4.0 today, 10 years, a decade since that first figure, we would talk about this model, and I'm going to give you a simplified model here. So these triangles, they represent enterprises, and in the terminology we're going to call them, or they are called, multi-level production systems. So these multi-level production systems make product, and those products we're going to call the devices and products in the field. So there's a one-armed bandit or a pokey machine, a washing machine, and a tractor. So all well and good, and that's exactly where we are. That's the Industry 3 version. So in Industry 3, data flows from the top of the enterprise, from the ERP system down to the sensors on the machines, and that's it, and flows backwards and forwards. However, what Industry 4 brings to the party is a vision, and this vision is this horizontal integration of these enterprises, and we're going to call them value chains. And it's they're going to get integrated horizontally and vertically. So that's what Industry 4 does. And of course, there's people involved, the stakeholders in manufacturing, and the stakeholders at the device level, the customers and the users, and they interact with the devices. So those devices are products, essentially. So those products that are out in the field are potentially themselves Industry 4.0 products. And the production system is now an Industry 4.0 production system where the stakeholders interact with that. And so there's a quote on the right-hand side, and I think it's useful to sort of break that quote down. And this is by a guy called Professor Alexander Subik, at the time, who was working at Swinburne. He's now back at RMIT. And he talks about this complex framework and this idea that there's full integration of these cyber physical production systems. So that's this multi-level production system, those triangles on the left. And he's talking about intelligent products, which of course are the devices in the field, so an intelligent washing machine perhaps, and the network and the systems, they're all connected. So the production systems, the products, they're all interconnected securely, and they're all speaking to each other by using standards and communicating and cooperating with each other. And the whole idea that this is without any human intervention or minimal human intervention. Now, the thing to take out of this vision is that it's not expected to be here for another 10 years. That's that future, but it's not today. The point is, if we look at that picture and we just cut it up and maybe add a few people in there as well, you can see that it's really Industry 3 evolved. And that's what I want to sort of talk about, to emphasize that digitalization is something that we can do today, and that it may be difficult, but it might be something that's not thought of doing, but it's actually not necessary to go through the stages. And in fact, digitization itself is not automation. I've just highlighted that here. Essentially, that everything about the figures, the mechanical loom, the production line, the mechanized line, the carcasses and the line, and the people in the office can all be connected. They could all essentially be wirelessly connected with each other. And of course, that's what we've got in our pockets. And that's this collection of smartphones and devices that were there in Industry 4. And the thing is that this narrative about the whole of these industry stages, Industry 1, mechanization, assembly lines, 3, automation, and 4, digitalization, every single one of them was all about labor saving and about productivity improvement. So engineers, and this is back to that complexity concept. The complexity, I would argue that it didn't really increase. In fact, I would argue that it's actually decreased in the last 20 years. And but all of those steps and all of the productivity improvements were about engineers or stakeholders applying the tools of the day to make, manage, and control things. And these things are products, they're people, they're processes, they're whole factories, their offices, and their businesses. And that's it. That make, managing, and controlling in order to gain productivity improvements is really what industry, all these, it's the function of business and industry to do those things. And to do it, they all require that insight and knowledge of the thing. So the people who are in a really good position to do this are the stakeholders and the business people. And for example, the operations manager or the person on the factory floor with a lot of information and a lot of knowledge about the production process. But what they lack is that capability of digitalization. So let's try and make digitalization simpler. And that's the aim. And I've got this is digitization is not automation. Well, they're not quite, but they can coexist. And they can be applied at multiple stages and at multiple levels. And so one thing I wanted to sort of bring into the business here, that Industry 4 that we can do today is essentially not about the smart factory. It's all about the smart enough factory. So what do I mean by smart enough? Okay, I just want to recap that. There's a triangle on the right-hand side, and the italics refer to the original headings under what was called the joiner triangle. Now, you don't have to be familiar with the joiner triangle at all to understand this triangle, this digital triangle, but it's useful to sort of maybe go back and look at that, perhaps Google it if you want to. But the concept of smart enough is that we're going to focus on productivity and compliance. That's why we're going to digitize a process. We're not going to digitize it for no reason. The business need we want to improve our productivity, and we want to potentially also improve our compliance with our own internal standards or our own external standards. And that's a sort of a factor that is related to quality, of course. We want to do this, we want to be driven by the data as well. So we want to, when we look at enabling or digitizing our systems and our processes, we're doing it for a purpose, and that's to get data from that to make valid data-driven decisions. So the data itself drives our decision-making process. And the purpose of that, of getting data straight away, is that we want our process to be transparent. We want to get that information very quickly. We think it's lean. I'll come to that in a minute. And the idea is to leave, and this is where we can start to see how we have to change our focus, is that we're going to leave the control and the actions to the experts and the systems that are designed to do
It's
that.
not mine.
So those things that we're going to do, we're going to close that feedback loop by the operator and the manager, or the stakeholder, I guess.
10th of July.
And what we're going to do there is we're going to look at this, and this, I'll go back to the bottom right hand corner, which I haven't really touched, that concept of a single source of truth. In the joiner triangle, it's talked about, this is actually a triangle that represents not just a strategy or not just a concept, it's actually a strategy or an organizational structure as well. It was used in Ford, by the way. But if you're all in one team, the concept is that everyone understands what's going on. And in a sense, a data type relationship of that is having a single source of truth. And that's about not repeating yourself. There's a concept of software being dry. Don't repeat yourself. And this single source of truth doesn't mean to say that it's just one monolithic database, for example, but it just means that you don't keep repeating the data, and that you access the data through various services. Okay, so let's move on to the next slide. And this, I hope, will finally sort of wrap up why I showed you that meme in the first place. On the left, and you can tell it's old because it's in black and white. It's not a modern fancy graphic, but it's out of a book, a very interesting book, and it's called, this figure is called it's 10 steps to integrated manufacturing production systems. Doesn't quite roll off the tongue like Industry 4.0 perhaps, but it's an IMPS, and it's straight out of the book by a guy called JT Black, who wrote it in 1991, called The Design of a Factory with a Future, which I thought was a very snappy title, because if you don't do these things, you won't have any future. That's what his drive was about. But you can see there now, we talked about lean manufacturing, we just use a term, but these are steps. What you can see here is a chap with his just-in-time briefcase, taking the strides up this effectively these steps. And that's essentially stages of organization of a production system into, first of all, manufacturing cells, then reducing the time it takes to exchange dies and tooling. And then you integrate quality control, you integrate your preventative maintenance, you balance these lines and make sure that your throughput is going at a nice sort of takt time process. And you link your cells with a Kanban type systems where you're pulling information through the cells, reducing the amount of work in progress, and then you interact with your vendors and potentially help build programs where essentially, if I use the Industry 4 terms, it would be that horizontal integration of these value streams. And then finally, once you've standardized and organized your production process, then you look at automation and computerization. Now, I would suggest that is okay, and why would that one do that? Well, okay, the computerization in that stage was essentially it's at that point that you want to link your production systems which is those 8 levels in the lower level, to your management systems. And that's that computerization step. If you look at what I would call a technology-driven solution, this is and you'll see if you want to find out more about this. This is from there's a link in the bottom of there that it's an Acatech document. See, maybe I should digress a little bit. That Industry 4 in Germany hasn't really worked, or didn't really work initially. It was a very slow start, and one of the things that there were many steps taken to fix that, and one of them was Acatech developed this concept of these levels of Industry 4. And the interesting thing is that the first stages of Industry 4, in fact, not even counted in Industry 4, was digitalization. And digitalization involved computerization and connectivity. So that's the first stages. And those stages are there to sort of reveal things about your process. And it's only when you do those things, I've just highlighted the fact that they're sort of essentially the same level there, that you start to get visibility of your process. And visibility is maybe the first Industry 4 level about why you would connect and computerize your systems, because you want visibility of your processes. Now, if you follow the previous workshops, we focused on this concept of the smart enough factory concept and the factory in a box. And that concept there was looking at really visibility and predictive capacity for simple models about your production processes. So not out there at the 2030 level, but essentially what can be done now. And we can do perhaps 80% of that large definition of Industry 4 right now. But I think by wrapping it up in that more complex autonomous response activity, that adaptability framework where everything's fully automated and essentially the factory is starting to make decisions for itself, very much like HAL, which incidentally is one of the latter definitions of automation. Dominance, I think it's called. We then see, we can get a lot out of Industry 4 and a lot out of digitalization without going to that sort of thing, to that sort of future. And we can do that today. And so a more holistic journey might be this, that really we overlay the two, and that integrated manufacturing system that's described links very nicely into step 10. And really the point is that this is an alternative definition for Industry 4.0 perhaps, is that Industry 4 in itself, in those stages there, actually express why you would want to digitalize. And that's it. And it's a way of connecting the production and manufacturing systems to the management system. So it's a sort of a link between sort of IT and OT. And I don't want to labor the point, but operational technology, you might hear the definition that it's information technology for the non-carpeted areas. So that's it. That essentially, if we take those two figures, we can see how they link together. And I've highlighted it. Hopefully it's going to pop up there. This concept of value. And if you see the background image on its own, that's actually one of the issues about Industry 4.0 that, or digitalization, that people don't see the value in it. But the point is that a value only starts to be expressed when you're doing something. It's like seeing what's happening. But here, when you link the two together, you can see they're actually, as part of that automation and computerization activity, that's leading you on into the next stage. And I think that holistic journey is something to be very aware of. And let's just come back to getting value from Industry 4.0. In Australia, 60% of businesses, and I think this is going to be relevant around the world, but there's no value to the Internet of Things. There's no clear value to digitalization. And now I've highlighted a bit of how to get there. I've maybe given the game away that there actually is, but that's the whole point. I want to make sure that game isn't one that's hidden from people. But the real other factor here is that digitalization is not usually the core business. So companies, even though they think they might want to digitalize, might struggle with it. And then, of course, they then struggle with the fact of how it's going to bring value to the business. So I'm going to summarize the entire first presentation in a couple of slides with a bit of luck. And I just want to point out that there is an indirect path to value. And it's this is how Architect solved it, you know, with these with their document, their maturity index and their stages of Industry 4. Now, to cut a long story short, in the red part here is really what this figure is all about. And what it is that an event occurs in production, and at some time later, this event is reacted to. And then finally, down here, there's some countermeasure taking place. Now, so it takes time to react to events, and this lag is sort of latent, that has been shown as latency. And this time delay costs money. So I'm not going to read what that is, but I will do it in this one. So here we have an Industry 4.0 system, and in this system, those latencies that are highlighted here, that were in the previous figure, they've all been squashed up. So event occurs, and a countermeasure takes effect. And so what Industry 4 should do, once these technologies are applied, it should take less time to react to events. And that quicker reaction time costs less money. And that's the whole idea of value from Industry 4.0. If we think about it like that, I think it's sort of very straightforward. So an event occurs, and much quicker on this loss sort of function, I guess, we now get a countermeasure that takes place. And so we don't lose value. And what the figure on the right, or this area in the center of the figure here, what I've done here is, or that's from this document essentially, is highlight the technologies that reduce those latencies. And on this side here, those maturity stages that are in that previous figure, this concept of computerization and connectivity, and visibility, predictive capacity, and transparency and adaptability, are sort of associated with technologies that provide real-time information, visualization, and essentially cyber physical systems. Now, you'll notice that I haven't had anything in that B analysis side, which is the big data side of Industry 4.0. And that's essentially one of the reasons why the approach that we've picked with the Smart Enough factory tries to minimize that. There is, of course, forecasting and what have you, but the point is that if we keep the information that we gather simple, and we understand our process to a certain extent, the point is that some of those analyses are not necessary to adopt in the in the short term, and we can get, as I say, a lot of value today from simple digital or digitization techniques. So I just want to cover briefly again the tools that we're going to use to determine what we want to implement, and that's really about understanding what is it that we want to digitalize. And there's various tools that have come into that, and a lot of them are around maturity indexes, the concept of sort of knowing where you are in relation to your neighbors or your peers. And it's around product and process technologies and assessment of your current capabilities. And what I would hope that they will help you do is determine what for you is the best bang for your own buck. And now I've used a similar slide, but I'm just going to highlight. I'm just going to talk about I'm going to highlight the one in yellow. I'm going to talk about the VDMA implementation guidelines. You'll be able to find this online. It's not too much. It just don't worry too much about it, but it's a document, and I'll cover the important parts of it. But I do want to show you, and I've mentioned Architect before. Well, the response for Architect was to create a document that would actually create a maturity index, and it's been revised. But you'll see why I want to move past it very quickly. Now, we've seen the figure on the left-hand side. That's stages: computerization, connectivity, visibility, and transparency. But on the right is actually a schematic of how you determine for your business where you are. Now, I think that's just too complicated. There's about 70 odd questions. It's to do those questions, you would have to engage with Architect or the deliverers of that. I think it's Aachen University. And so it doesn't help us work out how that index is derived and the questionnaires that get to it. But I just wanted to show you that because I think it's just too difficult, especially for SMEs or to manage. And I'm not the only person that thinks that's difficult. These are the summaries of a paper that were presented at a conference, which is the development of an Industry 4 maturity index. Now, the interesting thing is that I have absolutely no idea what that cost utility analysis actually means, to be quite honest. However, I think the telling part of it is the quote. The analysis, the entire analysis of all of these different models, which were maturity models, capability maturity indexes, essentially, including, I do understand that one of those models is the one we've just looked at. And for SMEs, the analysis revealed that none of the existing models met the needs of SMEs. So really, I've included it there to show you that whatever the scale is, that none of them were any good. And the point is that an SME who wants to use, for example, maturity index, would focus on these points on the left-hand side. They want something, a tool that's going to identify where they are. It wants to be something that's well, these tools themselves are expensive, so they want a tool that doesn't cost as much and takes less time to fill out. They want a tool that's going to actually incorporate their own objectives. They want to see significant results. So that positioning is what I was highlighting. A lot of them do that. A lot of them will show you where you are in relation to your peers and your relation to Industry 4.0 as defined. But the next bit is an interesting one. They need support to interpret the results, especially from complex ones, and perhaps some help developing actions. Now, the next one's an interesting point because perhaps they wouldn't need support to interpret the results if there was no need for specialist knowledge, if there was an easily understandable methodology. And perhaps they'd also like to see it online as well. So without going into too much detail about them, there's a group called the VDMA. It's a German group. And that in response to that sort of issue, they created this very visual picture. These two very visual pictures, and they call the whole thing an Industry 4.0 toolbox. And it's the core part of a activity that you can run within a company using your own resources, perhaps getting someone in to explain the terminology, but essentially it's a graphical way of identifying either where your product is in terms of Industry 4.0, the products on the left, or your production system on the right. Now, if you remember from the definition, going back to school here, we remember from our earlier slide, we talked about that Industry 4.0 was developing products and processes that were ultimately into that moving to the right-hand side there have been self-optimizing or independent, or having sort of agency, I think is the right word. So if you look at this, the figures, there's quite a lot to them. They're both have this triangle, and this represents Industry 4 at this right-hand side, and where you are, and Industry 3, I'm just going to guess the state of the art now, or where you are now. But the point is, you might be able to identify either in your products or your production systems where you are now. So if you put it even just a marker pen here, and you went straight down the left-hand side here, that would be where you are now. So that would be an indication of your maturity of your products in this Industry 4.0 space. Again, on your production system here. Now, I'm not going to labor the point too much, but the products that you make sort of are externally facing. They're facing your customers. So your customers can see what Industry 4.0 capability you have in your products. Your production system's internally facing. So you may not make a product that was an Industry 4 product, but you might want to use a production system that was an Industry 4 production system that you were much more across the right-hand side here. Right now, I'm not going to read all the headings out, but it's a very useful graphical way of identifying, your current state and perhaps identifying where you want to be, and identifying where you are and where you want to be is really the toolkit that's really useful for determining what it is, your business sort of plan essentially for Industry 4.0. I'll come back to that. I'll talk about that in a little more detail on another slide when we see actually an example of an Industry 4.0 application. And just to highlight what this guideline's meant to do, as I've sort of tried to highlight, it uses your products and your processes to determine your internal and your external capability of the business. The outcome of it is actually not full implementation, I must admit. I was surprised when I really discovered that essentially what it does is it's a process to create an internal or a business model of what you want to do. And what's missing is a strategy for how to implement it. So their concept of implementation is actually creating an application concept, not necessarily actually building it. So really, some activities that we've done in Australia have been around helping companies get a capability after they've defined, even a very simple capability, after defining a strategy, or sorry, after even defining what they want to implement. So identifying something to implement. Now that quote is actually quite cutting. If you do get a chance to look at these slides later, it's actually from the same group, this Fraunhofer Institute, that reviewed the models. They said about this one that it leaves you in the lurch when it comes to implementation. And I've mentioned the factory in a box. Now the factory in a box is a physical implementation, but in a sense it contains implementation patterns that you can copy, just like knitting patterns. It's not necessarily going to really take you from an abstract sort of concept into this. It's almost taking the concrete and you have to work backwards to see how you can abstract it. But it's actually having concrete examples, and plenty of them is very useful, because you can identify, if we have enough of them, you can identify potentially applications of your own into your own company. So that's the aim. I will just mention this, that VDMA themselves perhaps overly simplify the issue, and they do state themselves in their introduction that Industry 4 does not represent any value. So of course, I think that puts themselves on the back foot. But I must admit that it's really interesting that they say that's to counter that. What it does mean is that every company has to create its own view of Industry 4.0, which is, I guess, where we're talking about here. The digitalization involves understanding your own processes and what you want to do. And this concept of all companies regard it, or many companies regard Industry 4 as a challenge. In fact, I could read the entire thing, to be quite honest. There's just so much in this very simple introduction that they highlight that concrete solutions lie as much in the dark as the question about what Industry 4 actually stands for. And essentially, that's one of the reasons that prompt for that meme, that if you say, well, okay, let's just throw that concept of Industry 4 out and let's just focus on digitalization, it means we don't have to define what Industry 4 is. But we can't help ourselves. We have to come back to those definitions, but that's it. That's what it's really about. In terms of a business process, you really don't care what it's called. You just want to be able to apply it to get value for your company. So finally, we're on to the how to do Smarter for Industry 4. And it's really about I4O for all types of organizations, not for just automated manufacturers. We're going to talk about it from a small company perspective. And again, we're going to, like I've said, we're going to highlight this focus on digitalization for productivity and compliance. Now, we've seen the triangle. I just want to rehash that. Just remember, we're talking about management data. So that's what's going to go on the next bit. So we have this concept of this digital triangle, this strategy we can use, this digital strategy, and we're going to focus on management data. So what is management data? And actually, that's a screenshot straight out of Sutton Tools. In fact, that's our production manager, who's I didn't No, I don't know. I don't know if he knows that he's been captured quite nicely in that tablet screenshot there. But essentially, that's a dashboard that's on the wall. It's also available as a web page, and it presents that management data. And it's a simple stuff. And you might want to talk about it like this: what are machines or my systems doing right now? And that's simple things like machine state. Is it idle? Is it busy? Is it off? Is it on? We can use that information to support lots of things. We can look at process health, for example. That we can look at our accumulated off time. Has that increased over a period? We can use it for logging times overall of usage, and so we can actually use that then to look at our preventative maintenance schedules. We could use it for reporting machine faults. Tablets and very low cost tablets are available very easily, and it's very simple to have a touch screen and to actually might have the top 5 failure modes and be able to pick those from a list to identify a machine fault at the time it occurs. We can also talk about this predictivity concept. Things that we'd like to know was, what are my machines going to do next? And if we have a very simple model of our machines, potentially we can very easily determine what they're going to do in the future. And so the concept might be that we might do that for forecasting or achieving targets. And instead of waiting till the next day to realize that we didn't meet a target, you could actually be looking at those, identifying that you're not going to meet the targets today, and perhaps do something about it now, before the shift finishes. And if you notice, actually, that's a nice happy picture there. Everything's green. I think I'll show you later on. There's an example with things that are less green, and perhaps it might be more obvious then that how useful it might be to see things that are not going right, rather than everything working very well. And of course, we can find out things like utilization, which we might want to look at in terms of reporting. We can also use the same type of tools to look at where your assets are, and these are things that move around. So it could be, and the things that we might be able to find out about those are where they are. The transparency we get from that is, where are they located? And that's potentially outside of your ERP system if you have one. And so we want to be able to see WIP, queues, and bottlenecks. And something like this sort of screen would be something that would give you that. We have underneath the pop out on the left, we have a concept or just a very simple plan or map of where things are. And so there's jobs which they all start with undefined essentially, but these are all RFIDs. And they can be associated with people or jobs or parts or bins or whatever. And we can see where they are. So we can visualize where our work in progress is. We can also dig a bit deeper. We can find out how long they've been at these places. We can also find out how long they've been between places. And of course, these locations we choose are not necessarily aligned exactly with our ERP systems. It gives us flexibility. So here we've got a screenshot of the real deal. This is I can't tell you exactly what time it was because there's not a date and time, but that's a live screenshot of 5 bottleneck machines in a drill production system. Going from the top down, they've got their names and their identifier. We can see their immediate state. And we also see to the right of that immediate state, we see a green circle, or 3 green circles and 2 amber circles. What those amber circles represent is that in the time left in the shift, it's possible they may not meet their target. So we have an expected total. If we skip down below the current indicator, the donut, we can see an expected total. And below the expected total, you can see the stopped time for the shift. But going back to the donut in the middle, we can see what target we're aiming at. And we can see our current fulfillment of that target. And then, of course, we have the previous shift information below that. So hopefully it's clear enough, but I'll read the headings that if it's not. But if we were to work backwards, and we have a visual factory board, how could we define what we want using from that production system list on the left? If we were using it, if we're using that toolkit to determine where this board, where would we be? Well, there's a few interesting ones, and this is perhaps why it sounds great to use these things, but it's a point where it's important for people to meet and to workshop these things together, because we can see that potentially, in fact, I'll reveal the first arrow. We might think that we want to analyze data for production monitoring, and that this is the vehicle for it, that a dashboard is what will do it. Well, possibly we might also think that it's actually where we're using data processing in production because we want to evaluate our process planning and our control systems. Are we here? Is that what we're creating here? Well, if we did those things, well, perhaps we do need to have an industrial Ethernet interface or some form of connection, some form of machine to machine communication in order to do this, because this doesn't come from nowhere. Well, perhaps we also maybe need to think that we might need an internet-based portal and some data sharing. That's how we're going to get this data onto our dashboard. And finally, we might think, well, actually, do you know what? In order to do this, we're actually going to need to have some networking within the production system, and we need to have some uniform way of exchanging data between systems. And in fact, you'll see a little triangle shape here, which of course might be familiar with that concept of the enterprise. However, if we look a bit closer, we might go, okay, well, actually, do you know what? What this represents is some sort of man-machine interface. And that really what we're looking at here is some form of centralized or decentralized production monitoring and control system. And actually, this picture down here of someone looking at a computer looks a lot like the picture you saw of Keith before. Perhaps it's even here. Use of mobile interfaces. And of course, that's all in this man-machine interface area. Now, it's all well and good. Again, we could get tied up with that. But the point would be, if you work the other way around, if the arrows were facing the other way, perhaps if you were talking about man-machine interfaces, you would come into this sort of use, I want a mobile interface. I want to be able to look at production monitoring and control, and it's a MMI. Then you get to here. Okay, if you're looking at analyzing this data processing and production, these graphs don't exist for no reason, or that people aren't viewing those graphs. So potentially that again could face the other way. The point being that this is about data processing in production, and that you're not doing any data processing, or you're doing some form of storage for documentation, and then you're doing some form of analysis. But it's an interesting concept. Now let's say that's fine, but these red ones are a bit of a worry, aren't they? These red lines, which are sort of requirements. And the point is that the thing I'm going to show you, essentially, and this is where we can start to nail our jelly up. To get back to our jelly analogy, we want to really simplify this system. And so what you end up with, or what we ended up with at Suttons, and we've deployed it around in a few places in a few small companies and done some trials with companies in Victoria, and we've rolled it out into Queensland with some SMEs. Is this, and this is it sounds a bit too posh to call it this, but it's actually notionally called a microservice architecture. Essentially what we're doing, we're going to overlay a new system on top of the existing system. So what that allows us to do is not rely on having all of these interfaces. Oops, sorry, I'll try and, so what the point is, these red arrows here, this industrial Ethernet interfaces, this machine to machine communication, this full company-wide networking, and this ICT infrastructure and production could all be missing because it's all supplied with this concept. And it's a choice of hardware, essentially. So what we do, all those red arrow requirements are integrated into this smart enough factory hardware. So we use an IoT wireless system. It's an IoT 15.4 if you're technically interested. We're using the data exchange, this concept of uniformity in data exchange, we're going to use MQTT. The internet portals you saw there, well, at its simplest level, it doesn't require any connection to the outside world. It's just all internal. And in fact, it can be completely self-contained. And so that's onto our last one. It doesn't require this concept of an enterprise service bus. It's actually much more straightforward. The concept is that it can be expanded. Oops. The data is behind a firewall until it's exposed. And it uses interestingly, it uses the same framework and concepts as a lot of commercial offerings. For example, there's a Siemens MindSphere, which is a very nice piece of software, but underneath the hood, essentially, it's Node-RED and Grafana, and all the and a database. And the important, or the bits that make it complex and whatever, are essentially all the security measures to make sure that it can be offered in the cloud and connected to securely by their own sort of hardware. So it's not as open as the systems that this is. And that's the point, is that we do use standard hardware. And the emphasis is on low cost and that KISS principle, which is keep it simple, stupid. And we're going to see that very shortly. That's what's behind the system. That's the behind it all. We have a Postgres database, Node.js, and Node-RED. Node-RED is a graphical tool. This is an example of connecting a graphical program where these nodes are connected on a dashboard. We have sensors listening to data coming in from machines. We have low-cost Raspberry Pi here, and then this is the device that's done that. So what I'll do actually is I'll swap my camera over. That's actually I'll come back to that in a second, but I'll swap cameras. No, I won't. I'm sorry about that. I just turned that off by mistake. So what we have here, if you can see it okay, is a pretty simple, and I'll try and move my microphone so you can still hear me well. What we've got here is a very simple setup with what essentially is a legacy PLC. So there's a PLC, very out of date, power supply, a relay, and one of the nodes. Now this is an XB node. This is what we use primarily as an IoT device. We have plenty of IO. And this is just picking up a digital output of this PLC. So if I enable the outputs, the moment the PLC is idle, and you maybe hear it clicking away, and we'll come back to what it's doing in a second. On the left, if I move the camera around ever so slightly, so I've got a kettle on a base with another one. So that's another very simple connection.
Steve.
Yep.
I guess we are not able to see your demonstration. We are actually seeing only the screen.
Which screen? Do you know what? Yes, because I've got my camera open and I'm pointing at the thing. What I shall do actually then is what's the right way to see? Can you highlight me, my other camera, or do I have to do that?
Unfortunately, I can't do that.
Okay, all right. So if I stop sharing, so I apologize. Thank you very much, Pamela, for letting me know that. That's really important.
Thanks.
So I'll try and stop share. All right, that should have done it. You'll have just seen.
Yeah, we can see that now.
All right, so okay, so I've got two cameras. So they're my second camera, and I'm sorry, I've got a very short tripod, so I'll just pull it back a little bit. Okay, so what I pointed to was a very, very out-of-date PLC. I think it's the thing. So this is conceptually a legacy system. It's just simply running a little program. There's power supply, the PLC, a simple relay that it's operating, and we've added this extra device. So this is our IoT device essentially. So you can see the words XB on there. Hopefully it's not too blurred. But that's it. That is a connection what we do, and that's directly connected to the outputs of that. On the other side, and you can see the kettle base. Something very simple as well. So a very simple example where if a kettle is placed on the base, the kettle trips a switch, and so the switch is operated to say it's idle. If it's busy, when the kettle's actually switched on, and then when it goes off, it goes off. So that's a very simple use of hardware, just 2 bits of information. What I'll try and do is go to the dashboard and show you what that looks like, the data coming in. We'll have to share again, so I'm going to just share a screen and pick the right thing. Where are we? I'm going to pick Firefox, but I'll need to move the tab to a different. There we go. So let's get to the summary information. So there's the kettle and the if I take the kettle off the base, you can see that it now goes to stopped, and then it's idle now, and the switch goes down, it's busy. So that's a very, very simple bit of information that we're gathering from those machines. So live data, there's another example further on. Let's see where we've got the summary, heat map and timelines. If I just scroll down here, you can see I've just skipped over a few things, but there's if you if you looked behind me, you would see there's a UV sensor actually hanging in a fly killer. So I'm using that to pick up the output of a UV sensor, and then on the bottom right there's the PLC output there over time and the status, and on the bottom left there's the kettle. So using some very, very simple data acquisition devices, we can actually just get data very quickly. Now, how do we get it into Node-RED? Or how do we get it into this software? Well, this is Node-RED that I mentioned before. And in fact, depending on how well this updates itself, I'll just clear the data here. But every time something happens, there's an array. You'll see these arrays on the right hand side. So every time an event happens for the kettle or the PLC, we get a stream of data. The one from the you might see it, my cell, my factory, my UVA device. That's actually every 2 seconds is actually pushing data out, whereas the other systems are all based around events, so they're event driven. I'll just turn them off so we don't get too distracted. But and we'll just see the 0D 7D coming in. But in order to program it, we don't need to be too much of a computer programmer. This system was built by IBM, and as I say, it's actually the core part of the MindSphere. But it's a completely open source tool, and all I'm using is a browser. The hardware, the last part of the hardware is actually a Raspberry Pi, which I didn't show you. But we're looking at the Raspberry Pi's interface, and we can see that we've configured an XB to listen here. If I open it up, we'll see that what we're doing is, it's called configuration over customization. So essentially, if we know a few parameters for these devices, we can set them up. So there is some code. We have to do things like create sort of simple, this happens to be a language called JSON-ARTA, which is related to JavaScript, where we're looking for a particular payload type, and we're looking for a particular device. And if we do that, we're going to actually combine this string, which is my factory, my cell, my machine, and then combine it with this thing called payload.remote, and that becomes my that that becomes my topic for my message. So this is all about creating an MQTT stream. And in order to publish it, the data flows down these wires. If we happen to have a payload value of this one, we then invert the data bits. We swap them over. If we have a 1, we swap it over. If we have a 0, we turn it to 11. If we have a 1, we change it to 10. Otherwise, we'll leave it at 0 because we want to make sure that this is all positive logic. And then we send that straight out to an MQTT publisher or via a broker. And we identify the server here. So all of this background to the dashboard is done by dragging and dropping elements from the left hand side, wiring them together, and then deploying them. And if I was to do that and deploy that, I think if I hit that on the left hand side, I'll just get the payload of the current time. So let's deploy that. Now, hopefully this one might muck it up. So I'm going to add another wire between here and here because I think that one might actually not transfer that without change. In fact, there we go. You see that this one did actually lose the payload, but that number happens to be, if I click it a few times, happens to be the time. And that's the time where I am, 7:31. So that's how essentially that works. I can delete those and I can deploy again, and that's done. And again, that's how the dashboard's built on there. So I'm not going to focus too much on that, but I wanted to show essentially that it's not something that is too difficult for a mechanical or a production engineer to do. And that's because it's very graphical and it's something that's actually within the capability of most technologically minded or individuals who may be used to programming PLCs. And so that's someone that's likely to be involved in production right now. What is new for them will be managing a database, for example, and the framework that we've put together for that is a basic data warehouse framework. But that's potentially the harder part to this. So each of those, there's various pages here. So there's a test of time zones, a publisher, the heat map that you saw there. You know, I've got this connection to the cells. We do some changes. We switch by topic. We set a voltage. We switch by label, and then we end up with these displays up here. So these are. It looks potentially harder than it is, but essentially data just flows down these wires, gets transformed and modified, and then ends up potentially being displayed or modified either as a graph or as a value or as a graph. And so again, just to sort of highlight what we've just seen here, this fridge, the D4, the fabric, the resin, these flow heat map values, and the UVA 1, 2, 3. If we look to the dashboard again, we'll sort of see this concept of a dial and the data here. So fairly straightforward to do. Maybe I should show you how easy that is to set up. Essentially, this configuration is just configuring the label. What happens when you get no data? And all it requires is the data entering it to be in the form of a message.payload. So inputting a message.payload containing a blank array will clear the chart. But essentially each input message.payload value will be converted to a number and then shown on the screen. So this setFlow.heatmap is basically set this flow to the payload. And that's it. Off it goes onto the display. So that's this dashboard here. That's what's happening here with the data here and with this dial here. They're both stopped. I'll just go over and just show you that they're still alive by pounding on the kettle a few times or taking off the base. and interacting with it. Now, it might be worth looking at this for a second or two and just explain, why I've not got 0 and 1, why I've got those intermediate steps. Well, perhaps it might be that if we can see my mouse, if I was to look at the, if I want to look at utilization, I might be looking at the transition between sort of 0 to 0.3 here, and then down to here. And this time between here and here might be my utilization period. And this, I might also want to separate that out from my busy period. With something like this PLC, which is moving quite quickly, these 10-second cycles, I maybe just want to count those. I don't want to add them up. So the point is that it's back to that idea of what you need to know. What is your Industry 4.0? So if I go back to sharing my presentation, I'll just try and summarize what we talked about there, and hopefully highlighted that these are the parts that make up the whole for Node Red and the dashboards, for example, that you saw. I'll come back to this one in again. Okay, the last part is actually, I'll actually come back to the presentation. I'll just finish this last little bit off, and then I'll come back to that point that I was trying to show. Now you'll see that in the last slide, and what I was getting to there is really something I'm going to summarize with, and what we've talked about earlier is that getting your own sort of concept of what Industry 4 is, that business requirement, I think, is the important part. So we've seen the hardware, we've seen how it interacts with reality. I've given you an example. I've shown it's based on sort of fairly simple, straightforward hardware, and the configuration of this hardware is done through tools that the company supplies. So that device has a certain amount of input output, as well as on it. So this device here, oops, sorry, my mistake. I'm trying to show to get a, there we go. So this device here, this device is what we build the backbone of the system on. It's a relatively low cost IoT device with a number of inputs and outputs on it, and those inputs can be set up as digital inputs or analog inputs. So remember that concept of the triangle that I showed before, where we have the enterprise as a triangle. Well, this is just the final part of this, that triangle is discussed or known as an ISA 95 automation sort of model. And what it highlights is that an enterprise is built up of different levels or layers of systems. The top level, you might have an enterprise resource planning system, an ERP system. Below that, for operations management, you might have a manufacturing execution system. Below that, some form of SCADA or HMI, that's a supervisory control and data acquisition system, which in turn is connected to PLCs, and those PLCs in turn are connected to signals and sensors. And this triangle is quite nice because it sort of shows essentially what is the timing requirements of these different layers. And that when you get down to the PLC level, this microsecond and millisecond control is very important. Now, that's the bit that we're going to leave to the experts, which is the systems that are in place, the PLCs. And what we've got on here is essentially what the smart enough factory is. The smart enough factory is taking data directly from sensors on the floor, directly connected to either sensors that exist on PLCs or adding new ones, and they're presenting it on a dashboard. It's capable of showing data from our ERP system, from the manufacturing execution system, and it does that, and it shows it to the operator or the stakeholder for them to close the control loop. So that's where they're talking about the loop being closed. But as an SME, it's quite possible that these layers that don't all exist. It's quite likely you don't have a manufacturing execution system, a dedicated one. You might have an ERP system. In fact, your ERP might even be something that's done in Excel. And lots of small companies do run on spreadsheets. So that might be your enterprise resource planning system might be a spreadsheet. You might not have any SCADA systems, or even any HMIs for that matter of fact. You might, like I say, you might not have a dedicated ERP system. In fact, you might not have any of those layers at all. And the point is that this system could be fitted, provided we can get data from a sensor that you want to know. So that's it. So that's the digitalization aspect of Industry 4.0. If you keep it low cost, and if you look at using a system as an overlay, it means the least impost on your existing systems, and it means you can still get data and make decisions on that data, and utilize the digitalization tools that are available now. And in fact, tools like Node-RED that are freely available came out of IBM, and it relies on web browser technology to provide that, all for free essentially. That ability to create interfaces and a platform to present that data. And so all of that is incorporated into what we've called the factory in a box. And that's a tool that we've used in Australia with SMEs to teach them about Industry 4.0 and to give them the kit to practice. And the reason for giving them a kit is essentially that it's that the issue is that it's not the core business of the companies. So what it consists of is it's got the same hardware and software as the visual factory that you saw. It's completely open for modification. It utilizes open source tools. And you've seen the Node-RED. I didn't show you the Postgres database. The boards, the simulated machines on there are based on Arduinos, and you see a Raspberry Pi. So what it actually is the board represents a factory. So it's a factory in a box, and on the board are mounted two machines that are simulated machines. That's one here and one here. And on the machine, we attach the devices that you saw attached to the PLC there. And they are wirelessly transmitting data every time an event happens on this simulator machine to this device that's fitted to this edge computer. Now, the leads, you can see they're obviously USB leads, but they're just powering this device. So there's no connection between this device and the machine, apart from the edge computer, I should say, except via wireless. And what that then does, this small Pi contains the Node-RED, the database, and the broker. And if you connect that to your computer via this Ethernet port, it can just work standalone as a system. And then when you're ready, you can deploy these devices. You can take them off the simulated machines and actually deploy them onto your actual devices if they're compatible. And these are relay compatible, these ones. So the point is that it creates a tool that's actually that's a low risk to engage, and you can engage with it on many levels, and it's a low cost and low risk to engage, and it's going to assist you in the problem of converting data to knowledge. And especially this might be familiar to people in the UK as well over there, is that it's a shoestring approach to Industry 4.0. And I think that's a very important thing to highlight, that it is low cost, and the whole aim is that it's low cost or bust essentially. And so to summarize, this whole concept of digitalization is we want to be able to move from a vision to a business model to an implementation. And if we look at digitalization in itself, even if we don't want to sort of have a deep knowledge of Industry 4 itself, the point is that this digitalization activity is going to give us this concept of us being able to manage to try and minimize that delay it takes from seeing something happening on the floor to actually being able to take some action. And we do that because we don't just digitize for no reason. We're doing it because we want to focus on this concept of improving our productivity, as well as our compliance to internal standards. So at its simplest level, an internal standard might be that we need to do some activities and some actions over a certain period of time, or to comply with our needs for utilization, for example. So those things we can check that we're actually doing those things. It might be that it might be just be a physical check that that we need to do, that can be done by simply using the RFID tags, which I realized that it's sat there and I haven't shown you, but that's another story. I'm just conscious of the time. And I think I've tried to show that you really want to have a strategy. And if you don't have a strategy, that you won't know why you want to digitalize. And that digital triangle is actually quite a useful one. It's actually even those 3 simple points actually focus the mind on why you want to digitalize. And I didn't really go into this, but the point is that what that factory in a box system and the system I showed you does, it's software is often talked about as being opinionated. And the idea with this is that we actually create a framework. So this framework is one that you don't need to choose yourselves. It's actually pre-set up, and it means that within that framework you can develop things and without having to sort of do too much analysis and creating your own sort of set. But your journey is going to begin when you identify a real business problem, and that's the main focus. If you have a real problem, then it actually helps to identify what it is you want to achieve. And so it's not the technology that you should concern yourself about, but it's actually what business need are you fulfilling. And the point is that to implement a smart enough solution, you actually need to have a real business problem, of course. But then once you understand that, once you understand the digitalization of your process, you yourself will get opinionated on what will give you bang for the buck. And that's the key point there, is that what for you and your company will actually, be a reason for adopting some of these digitalization techniques. And I want to acknowledge a number of people that have been involved in this activity. The partners that were involved in developing the factory in a box, that's the Defence Materials Technology Centre, the Advanced Manufacturing Growth Centre, RMIT and UQ, the capstone students we've used through the years, some business information students, cybersecurity students, some friends and colleagues at RMIT, Sutton Tools, WIL students, that stands for Work Integrated Learning, and then finally, of course, the Digitalized Surface Manufacturing Network for the opportunity to present. So thank you, and thank you for listening. That's the end of my slideshow. I'm going to change video. I'm going to stop sharing, and I'm going to swap to my other camera. And thank you.
Thank you, Steve. Now, if anybody's got any questions, do you want to post them in the chat? That will be helpful.
Yes, I didn't have my chat open. That would have been very useful, wouldn't it?
So, by all means, voice a question. Unmute your microphones if you've got any questions for Steve. Okay, Dave's unmuted, so that's encouraging. Over to you, Dave.
Yeah, I think one of the things, Steve, which comes out again in your second presentation is this idea of one source of truth. Because when you deal with lots of companies, the thing that strikes you is they don't use data. So there is no one source of truth.
That's an interesting point, David. I think it's that's it. It's realizing that you actually can be making data as well as making a product, and it's not well. And I guess that gets to the point of that the data in itself isn't that useful. Oh, okay, it's a precursor to knowledge, isn't it? Really, Unless you're collecting data on something, you're not going to be able to then interrogate it and work out what it is that you're trying to find out. And if you're not using your data from your machines to make decisions with, it means that you're not necessarily capturing what's going on properly, and perhaps your decisions that you're making are not necessarily based on any empirical evidence, I guess.
Yeah. So there's this disconnect between data and knowledge, because data does not necessarily translate into robust decision making if the knowledge framework is imprecise.
Yeah. I suppose that simple systems like this allow you to explore those concepts and actually work out what it is that is important to capture. From our experience when we're working with small companies, is that they may have an idea what they want to capture, and it's only until when they start capturing it that it actually prompts them to understand that's maybe not quite right, but at least when something is physical and they're observing it, they can then choose to change what it is. They're not constrained to not changing. And I think this allows this sort of system where it's low cost allows them to sort of to experiment themselves and to start to make decisions for themselves on getting confidence in the fact of what it is that they want to, the data they want to gather.
Yeah. And the other one which strikes me is the the importance of how quickly you make a decision. Too often people make decisions because they have to, because they've got to keep production going. And the quality of the decision making is obviously influenced on how you want to interpret the data. So if your data interpretation is poor, then your decision making is poor.
Yes, and I think that the aim is to try and to get information in a timely manner, so that that does back up that decision making process. Yeah.
Because in my experience, people aren't short of data, but they don't use the data in real time. They only use the data once they've got non-compliance.
Yes, that's a very interesting point, isn't it? When they start to decide to collect it, that we need to do those sort of things. Yeah. And then that's done for a short time and then potentially gets dropped by the wayside.
Yeah, and it's how can you make the data live, which then shows the people the importance of linking it to decision making in the business, which links then into these productivity and compliance discussions.
Yeah.
So to me, the open source tools you've described are really good if you can put them onto machines and start getting high quality data. But it's how can we use the existing data streams, which are not necessarily data derived off machines, but data derived in laboratories on assessing the quality of a product. So there's lots of data around. So a laboratory will measure the hardness of a coating or the chemistry of the coating or a thickness of the coating. And a lot of that data is just not used in any live event. It's only when it goes outside bounds that people's take an interest in it. Because the classic statement is the lab has failed this product. The lab hasn't failed it. The lab has just reported what it's seen. The thing that failed the product was the lack of understanding between the outputs and the inputs.
Yes, and that sort of time delay as well between the sort of lab test, and that's sort of long gone, perhaps.
Well, and if you're unfortunate, it's actually ended up in a customer product. So in your, in your vertical integration, suddenly you've got a quality escape into the real world. And then how do you chase that down and manage that risk? Which is where I think people are going on these digital twins in the bigger enterprises, where they're trying to bring noise and variance into the digital twin to help them begin to predict where the real world's going.
That was very interesting, because I always said, well, maybe quite a long time ago, that that there's an undertone song which is my perfect cousin. What I like to do, he doesn't, and he always beats me at Subbuteo because he flicked a kick and I didn't know. I didn't expect to say all of it at that point. But the point is that I reckon that the real factory would hate its digital twin. The digital twin would be its perfect cousin, and then it would be very jealous of it. And that's it. The twin needs to have the same slippery floor, the same, to have that same variance in it that the real system has, in order for it to actually make accurate predictions. So, and that's, maybe you could actually argue then that it's impossible to make a digital twin. Well, but there we go. I don't want to get into that too much. But a digital twin. You really want to have information from the process to understand, the influence on that hardness. What is it? Can you actually map anything from the process of creating that coating down that line? And perhaps, it's information from a process that allows you to sort of predict potentially if it's linked to that sort of potential failure of hardness.
Yeah,
early.
And that takes you back to your previous life, which is the use of viable statistics to begin to try and link all that together.
So yeah, look at
you first.
No, go on.
To me, it's the whole challenge really is how can we move ourselves into using data? Because we don't like to, because we don't like facts getting in the way of a good story.
Yeah, that's potentially true.
Yeah. And as the industry in service engineering looks inward, then one of the issues, I think, the reason they need to take and embrace the digital 4 concepts is a lot of knowledge is retiring out of the business.
Yes, that's a very important point, and I think that's the things that were done in the, and look, the things that were done in the past to try and capture that, the concept of expert systems, and then that's now sort of AI. But yes, the need to not lose that data, to not lose that information. That's the right term, isn't it? That knowledge, the process knowledge.
Yeah, because ultimately, if you end up with only one person with the knowledge, then he's bound to be right, isn't he?
Yeah, that's true.
Yeah. So as you begin to depopulate yourself with the subject matter experts, you can't even have an informed debate. So your decision making process becomes like your kettle, because you've only got one on-off switch, because you've only got one person with the ability to inform the decision making.
Yep.
And then their life experiences is only encaptured by what they have observed. Where if you actually can collect the data now, you can inform it on what many subject matter experts have observed.
That's very true, and I think there's a lot of systems that have got very good at actually doing things which would have been sort of notionally a black art, just by understanding more about the process. And that's, I think, grinding is one of those things which has improved no end. But yes, it's not wrong to think of certain things as art, but that knowledge, and that's where I get the sort of state of the art concepts as well. That process knowledge, if you can capture it, it does make it easier to make sure that that things that were common knowledge at some point don't get lost.
Yeah, and I think that goes back to this thing which you might have seen in your work, which is if you're not careful, you begin to reinvent the wheel, because the problem which was observed 7 years ago resurfaces, and if you're lucky, the subject matter expert remembers the problem seven years ago. But if the subject matter expert has retired, the remaining subject matter expert may never have seen the problem.
Well, that's a very interesting concept, and one of the, we didn't really talk about it too much, but we use a system called Confluence, which is it's an enterprise wiki, if we want to be. It's essentially your own Wikipedia, and what that allows you to do is store experimentation and documents and things like that about a problem and the solution at the time, and it's a store that's, we've got one that's, it's a decade old now, and that's useful because you're right. Reports that are written in the 60s that solved the problem on drill manufacture, another 10 years later, the same problem comes around again, and the people that knew about it then are long gone, and the results are missing. So yes, and in some respects, that's actually another form of digital twin, which I quite like. It's a sort of a store of data around company knowledge, and digital twins don't necessarily have to be a full simulation. And I don't know if you want to call it a digital shadow, but that concept of knowledge that you can store and retrieve and search on around a product, even if it's not the entire factory, but just around a product, is in some respects a digital twin of the so it's a twin's the wrong word, isn't it? But it's that digital sort of shadow or digital representation of that sort of collective sort of memory of the system, and that's very useful to store.
And I think
I'm going to have to bring us to a conclusion, because I was aiming to try and hit an 11 o'clock stop, because I'm sure a number of people have more meetings at 11. If that's okay, Dave, by all means, continue your communication with Steve, with email or whatever. I think these series of webinars are going to carry on, Steve, because they all generate new ideas and concepts. And I think the idea of the live digital twin and, a knowledgeable digital twin and whatever is an interesting concept, actually. And coming back to Steve's point about using knowledge, it reminded me of the expert system work. You try to encapsulate the expert's knowledge and have it available. So I think these all come together very much so. And I also remember, Steve, you looking at drill data from, what would that be, 30, 40 years ago? And
well, that was interesting, wasn't it? Because it was from drill data where they had just so much information that they didn't know what to do with it. Couldn't present it, and so then you end up looking at sort of those sort of tools for managing large data sets, which is something that we didn't really get onto, but the challenges of big data and small data, I think, are very important, and actually making sense of and interpreting those large data.
That was a statistical approach that you used, the multivariate analysis, to analyze data that they didn't know they got, really.
Mm-hmm. Because when you try and present those multiple variables, it's very hard to plot even, and that's that visualization aspect and that transformation, which multivariate analysis does to sort of push all the variance into the first few dimensions, allows those to be plotted as a example for the rest of it. And a lot of those tools are all used in sort of teaching sort of AI type systems and machine learning. So they sort of, it's quite interesting how they compare.
I think that's where the challenge is, Steve, to begin to reinvent what was going on, to make the connections, whether you call it AI now or your machine learning or whatever. And what's the best toolkit to use? Because it needs to be open source, because nobody wants to be vendor restricted. And so in the same way as what you've done with the data processing side with Node-RED and all the rest of it, what's the best toolkit for that sort of approach? Because that's where we are. There's lots and lots of knowledge. Unfortunately, it's totally disconnected into a common understanding. And that knowledge is fast retiring out the business. And in a few years' time, all of those problems haven't gone away, and they'll resurface, and the industry will be poorer. So you won't drive productivity up, and you won't drive compliance.
Yeah, look, there's just off the top of my head, the lot of tools that are Python-based tools, NumPy and SciPy and all those sort of ones. And my phone just gone off.
Yeah. If I had to guess what your ringtone is, I could have guessed that.
I thought it would be the undertones.
Well, that's just one of these portable ones, but yeah. I don't know. I apologise to hanging up on that.
Yeah, because
I think I am going to have to wind it to a close.
Yeah,
I think
that's
that
okay.
was a good end there.
Yeah. Okay.
Well,
all
keep
right.
smiling. Thank you very much, Steve.
Yeah, thanks, Dave. Thanks to everybody for attending. This will be available on the website, on the network website. And, you know, let's continue the dialogue, and because there's definitely a need for that. Okay.